again, and I'm very happy to have this opportunity to share with you our experiences of the last 5 to 6 years, the journey we have traveled to develop the Nile Basin Decision Support System, which is still on progress. So my purpose of this presentation really is to share with you what we have gone through and what we have observed and what we have learned out of it, in the hope of provoking more discussion from your side, and probably finding some other ways of doing things as well. So to start with, when I saw the one slide by Andrew, the objective of the workshop, which is about what challenges and finding solutions together. Decision support systems are all about this, meaning to support those kinds of actually participatory processes to find solutions for challenges in water resource management and development. So my presentation will be mainly focused on two things. First of all, I'll give you a very short introduction about the Nile, just a recap of, you can say, geography 00 probably, or 01. Then after, I'll straight go into the process we have gone through in the development of the Nile DSS, starting with what we call the needs assessment and the conceptual design. And then after, present to you again a very overview of the features of the Nile DSS, what have been implemented already, what is also coming, because as I've said earlier, is still under development. Then I will focus a bit about the development process itself, because there was some lesson out of it in my perspective on the development side, and a recap of lessons learned, but the way forward with no slide, that's more about my own, a few words about it. So, just the geography of the Nile, we still claim it is the longest river in the world, with 6,700 kilometers. It's basin area about 3.2 million square kilometers, stretching over 10 African countries, Eastern Africa mainly, and over 200 million population in the basin, and with very diverse actually climate, because if you start from, it's somewhere here, it is very tropical, very wet and humid, but when you go up north of this latitude approximately, is arid and semi-arid. So it's extremely diverse hydrology and extremely diverse actually cultural situation as well. So a bit of the hydrology of the Nile, the two main tributaries, the two main contributors of water flow in the downstream side of the Nile are, one is the river which originates in the Equatorial Lakes region, which ultimately we call it the White Nile. The other one is the Blue Nile here, which originates in the Ethiopian highland. There are also other rivers which originate in the Ethiopian highland, but these are the two really river systems, you can say. And the two rivers join here in Khartoum, at the capital city of Sudan, and then after collectively we call it the main Nile, or simply the Nile, and flows northwards and then finally into the Mediterranean Sea. There are a number of regulation structures that somehow conserve water for different purposes, for different uses. But the main one is actually the highest one down, in Egypt, with a very actually big storage of water, we call it century storage of water, which essentially regulates the full Nile flow, which is about 80 to 85 billion meter cube per annum on the average. So, main features of the hydrology are those rivers which originate from the Equatorial Lakes region. Because of the climate there, they are relatively less seasonal than the ones which originate from the Ethiopian highland. But on the other hand, the rivers that originate from the Ethiopian highland contribute 85% of the average annual flow into the Nile, especially at the entrance to Egypt. So, to say a few things about the different aspects of the hydrology, one major feature is, of course, the Lake Victoria Basin here, which is the second largest freshwater lake in the world, with an area of 68,000 square kilometers, and it is source of water for about millions of people in 5 countries. Source of water again for urban use, irrigation, fisheries, navigation, and so on. Main challenges in the Lake Victoria system are lake level decline because of, to some extent, overuse or obstruction, you can say, and water quality as well, and environmental degradation in the upstream part of the Lake Victoria. The other thing which characterizes this region is it's not yet developed well. There's a lot of potential for development, for water resource development. Next to it, another key feature of the Nile is what we call the Sud wetlands. This is one of the largest freshwater wetlands in the world. It has very complex hydrology. It's very seasonal, but the substantial part of it is actually inundated throughout the year. One major feature of this is about 50% of the flow that goes into the Sud wetland gets lost through evaporation, meaning approximately 16 to 17 billion meter cube water is evaporated annually from this wetland. So it is evaporated plus transpired, that's why it's ET, evaporation transpiration. Because of that, there's an interest still to conserve that water, but it has its own implication on the environment as well as on the livelihood of people living in that area, because they depend on the wetland for quite many things. So the other one is the Blue Nile system, which originates in Ethiopia, which supplies about 60%. Just one sub-basin contributes about 60% of the water at the downstream, all right? And there's huge potential for hydropower generation here. It has excellent gorges for reservoir, for dams. The main challenge is because the water is highly committed downstream, where, as I said earlier, this part of the basin is really arid and semi-arid, and the people there nearly totally depend on the water of the Nile. So main challenges here, when you develop the water resource here or here, then obviously there will be impacts downstream. So the countries have to find a solution or mutually beneficial way of developing the resources. So one thing I can summarize here is that the downstream part of the Nile is relatively well developed in terms of water resources, lots of irrigation development, a lot of power development as well, whereas the upstream parts are not developed. At the same time, they have huge potential. So it means, given the finite amount of water in the Nile, obviously there's a lot of dialogue between the countries how best to develop a system to result in mutually beneficial uses. So finally, the Nile Delta, especially this one, the flow here is fully regulated because of the dam. Somewhere here. It is arid or semi-arid, and there's no really significant locally generated water there. It just depends upon water coming from upstream. Highly developed water resource infrastructure. There is a decline because of population growth. The main challenges there are decline in per capita water availability. There's a deterioration of water quality is an issue there, and sea level rise, basically from the Mediterranean. And there's a lot of soil salinity problems in this area. So meaning actually any reduction or substantial reduction of inflow into the system can have adverse consequences. So there's actually a potential impact of upstream development on water availability downstream, because as I said earlier, they depend heavily on water coming from upstream, and upstream there are development potential, population is growing. So, upstream development can potentially have some impact downstream. So, these are just to give you perspective where the issues are. Okay. So, then the question is, okay, at the background, why an Nile Basin Decision Support System? Way back in 1999, 2000, when the Nile Basin Initiative was started, there was a lot of dialogue about how to move forward. So, one of the discussions led into the idea of having a Nile Basin Decision Support System to find and to help the countries in their dialogue on finding mutually beneficial solutions with respect to water resources management and development. So one of the suggestions were to have a Nile Basin Decision Support System. So these are some of the points are from those discussions way back in 1999, 2000. I wasn't there, but I was just going through the documents. So first, the Nile riparians are in the process of jointly developing, managing the shared water resource, because the Nile is a transboundary river system. So countries are coming together to find a solution on mutually beneficial way of developing and managing the resource. So to support this process, there's a need, which countries identified, for accurate information and common analytical tools. Up until that time, there wasn't any shared, you can say, knowledge base or analytical tools which supports the country's dialogue on water resource development and management. So this information provides a sound technical basis which help in decision making, but due to complexity of the Nile Basin issues to be addressed, a suite of models and analytical tools are required, because you cannot really address the whole issue using just one model. So because of that, there was a need identified at that time. You need to have quite a number of different types of models, depending upon the complexity of the issue you are addressing. So this is what led to the decision by the countries to develop a common analytical basis for joint development and management of the Nile water resources, which they call it the Nile Decision Support System. Okay, so this was, you can say, almost the vision for the Nile DSS, has been emphasized to be a common computer-based platform for communication, information management, and analysis of the Nile Basin water resources. Coupled with human resource development and institutional strengthening to provide a framework for sharing knowledge, understanding river system behavior, which is very important because, if different countries have different perspective or different understanding of the resources status, difficult to discuss, because the first thing is to have a common understanding among the countries, the status of the resources, how they can develop it, and so on. So the Nile DSS is expected or envisaged to provide the tools and the knowledge management system in understanding river system behavior. So evaluating alternative development and management schemes, which is very important because decisions obviously include or involve choice making among a number of alternatives. So the Nile DSS is going to support this. And supporting informed decision making from a regional perspective. With this vision, they also identified different purposes of the Nile DSS. At the policy level, it should provide the knowledge base, basically. It should have a lot of information management capabilities coupled with databases. So it provides a knowledge base which will help to do some kind of diagnostic analysis to even trigger policy interventions. Serve as information basis for policy and strategic analysis. It should be a platform for communication to facilitate the joint identification of development strategies, which is very important because this joint is really important when you work in transboundary river basins. Okay, at the planning and management level, it should help identification of cooperative projects that provide mutual benefits. So it will help the countries to identify those alternatives which are kind of what they call win-win. Basically means where people, all countries, or at least those participating countries in any project will benefit. Evaluation of impacts, benefits of alternative plans, assessment of trade-offs, and investment sequencing, trend analysis and forecast of development of hotspots. These are some examples of the purposes for which the countries agreed to develop the Nile DSS. This is really very high level, so it starts to really draw down to the details before you start development. That's why at the beginning, what we did was we launched what we call a comprehensive needs assessment for the Nile DSS. This needs assessment basically means to identify what kinds of information management capabilities do we need, and what kinds of, for example, modeling tools do we need, what kinds of decision-making tools do we need. And these are very much related to for what purpose you need the Nile DSS. So we started basically from the key focus areas for the DSS and what kinds of decisions do you want to support. That's really very much determines what kinds of tools you need. So these are some of the questions we raised at the beginning of what we call the needs assessment, which was done way back in 2007 and 2008. So, for example, what are the key thematic focus areas for the DSS? So countries have said it will help us in policy development, it will help us provide a knowledge base, it will help us in identifying mutually beneficial interventions and so on and so forth, which is fine. But what are the focus areas? Within what context are we going to provide that kind of support? So we have to identify really with the focus area of the DSS. What are the decisions to be supported in these thematic areas? For each thematic area, for example, if you talk about, let's say, optimal water resource utilization, then under it, what kinds of decisions are to be supported by the DSS? That was another question. What outputs should the system produce to support these decisions? Okay, you have a decision, let's say, optimal operation of reservoirs in different countries, for example. So to support this optimal operation, then what kinds of information we have to generate which will help in decision making? And it's more about, ultimately it's about providing information for decision making. Okay, so what are the main users of the end client, which is very important. For whom are you going to develop it? Who are going to run? Who are the people who are going to run it? And who are the people who are going to make decisions? So this distinction is really important for us. How do the users interact with the system? What data is available to support the development and use of DSS? Because data at the same time is a constraint, because you want to, model the system, but if you don't have the data, then obviously it's difficult, to use the model. Or on the other hand, the data very much detects as well the types of modeling or the details of modeling you can use. So what are the existing systems that need to be taken into account? Because at the time when we started the need assessment, some countries, not many, were already using some kind of modeling system, like off-the-shelf models, for example. So we need to take into account possibly integration of those models as well, because once we are used to some kind of modeling system, we want to stick to it. That means you cannot simply really disregard this. So it means there should be a way of integrating all these kind of things. And how to develop and deploy the system, and how should users be involved during development. So there were actually quite many questions which we needed to answer in the exercise of needs assessment and conceptual design. So the process we followed for the needs assessment was like this. First, precision support systems in many of our countries, at least in the Nile, were new concepts. So when we went out to all countries, because we had a lot of consultation workshops in all countries, in all 9 countries. So at the beginning what we started was with a 2-day kind of very short training for all stakeholders who were participating. Because we needed to introduce to people what are the decision support systems and how do they relate to water resource management and development, which they are familiar with anyway. So it means thinking about this, talking about decisions, talking about alternatives, and then linking them like the need for tools, the need for data, the need for accurate information in supporting those kind of decisions. So these were really vital, but we did it in all countries at the beginning of the consultation. Once we finished that, then we went into the national consultation. So the first thing is what kind of issues are relevant, especially from transboundary perspective. That was very important. So the institution has set up requirement, capacity building needs and data availability, and this resulted in, you can imagine, a wish list of issues. People say, I want this to be considered, I want this to be considered, and when you brought together this list from 9 countries, you can imagine some are overlapping, but there are many also which are not overlapping. So we are going to develop one decision support system. However, it can be customized at the national level. Still, the core issues should be the same. So that means because that we moved into what we call regional consultation, where people from the countries came together. Meaning at the first national level, it's only the people in the countries, but from different ministries. Power, environment, water, and so on. But when you come here, these people from different countries sat together at the regional level and worked through the list of issues to prioritize issues, because we have to prioritize and start somewhere. So this led to what you call agreed common priority areas. That means these were the 8 priority areas which we finally agreed. But just to go through them quickly, the first one is more about infrastructure development for water management, like dams, diversions, and so on. This one is more about what we call the non-structural measures, like operation rules and integrated operation rules and so on. So energy production is an issue for the countries because there's a huge amount of hydropower potential undeveloped yet, so it will be developed, and the DSS should support planning decisions to develop those kinds of resources. Agriculture and drought/navigation, watershed management. These are the 8 core issues which the countries wanted the DSS to address. Basically means actually the DSS should be able to support planning decisions along these areas. This still has to be narrowed down, but that was done later on. So water quality and climate change were taken as cross-cutting issues. As an example, this is the output from one of the consultations, the regional level. This is like a list of issues. These are the countries. So then finally, this kind of like number of countries where this issue is priority issue, and then this was how it was finally narrowed down. One thing you might notice, the water supply and sanitation is priority issue in almost all countries. But when it's more about like the country said finally when we start together at the regional level. This is more localized issue. It's not really a such transboundary because anyway the abstraction part will be taken care of by the modeling system. But this other aspects of water supply and sanitation better be taken at the local level as than at the transboundary level. That's why you don't see it in the A+2 core issues. So once we have that, obviously we took the key thematic focus areas, then identified for each one of them what are the planning decisions to be supported. For example, you say water development, let's say dam construction or regulation structure construction. What kinds of planning decisions are going to be supported? And this, again, to support these decisions, what are the key questions that must be answered from the decision maker's perspective? And this led to, like to identification of, to answer these questions, what information outputs should the DSS provide? All right. Okay, to generate this information now, what kinds of tools do you need and what kind of data do you need? There's some kind of iteration here because then you might say, I need this kind of data, but if the data is not available, obviously you may have to somehow give feedback and then handle this kind of situation. So this led to what we call the Nile DSS conceptual design. So it means we started with stakeholder consultation, identify the key thematic areas. From the key thematic areas, through decisions, questions to be answered, information to be generated, identify the tools for the DSS to basically fed into the conceptual design process. Okay. So, and that eventually was translated into like development, bidding documents, summaries of reference, this kind of budgeting and so on. Okay. Some reflection on the conceptual design and the key elements. Yeah, on one side, that's what I have talked so far, we're on the domain side. Basically means the water side, you can say. Now, the DSS is ultimately going to be like a software system to some extent. So, what kinds of elements do we consider, actually? Because when you think of the users, potential users of the DSS, they're not necessarily, all of them are not necessarily modelers. So there are people who really are interested only in the decision, not in the modeling part. So you have a huge spectrum, big spectrum of users actually. So it's very important that the ease of use will be a key criteria for the design of the DSS. Should be interactive, easy to learn, intuitive understanding for infrequent users. Meaning modelers should be able to use it, non-modelers should be able to use it as well. It should be flexible, expandable as requirements evolve, which is very important because imagine when the concept of Nile DSS was started, 1999, 2000. Now we are in 2011. We haven't yet finished developing it, so now it's almost 10 years now. Even since we identified the requirements, the conceptual design, which was in 2008, now almost 4 years now. That means new requirements definitely will evolve, especially when you see a system. They'll say, I also need this, I also need that, because before you had the system in front of you, you had some imagination about the system. When the system is in front of you, then you start to increase the requirement. This is what we are observing also in our development effort. So your requirements definitely evolve. The technology improves, obviously, and also more data becomes available. This means this actually requires to have a flexible design. Something not really cast in stone, things which you can expand, which is very important for us, so we have taken this into account. Modularity, again, not only one modeling tool, but you should have multiple modeling tools. Some of them are complementary, some of them could even be alternatives, because their use depends on data availability, for example. So data availability is not uniform throughout the Nile Basin. In some parts of the basin, there is lots of data available. In others, there is no data available. If you take rainfall runoff modeling alone, then obviously the system which you can use, where there is data, you have multiple choices of tools, because you can use tools with very little data requirements or with more data requirements. But areas where data is very scarce, you don't have much choice. So this type of modularity is very important for us to take into account. So it should be, again, openness, transparency. Don't forget this is actually partly or to a greater extent a transboundary tool. Transboundary water management tool, especially in the Nile where very little history of cooperation. That means transparency is really very important. So should be able, if requested, the source code should be reviewed. Again, very important about again, when it comes to data, the data we have currently also is to some extent subject to data sharing agreement by the countries. Meaning, there are some strings already on how to use the data. Your system should allow actually data security as well. Should not be open for everyone, because some data may not be available to what they call third party, for example. So this kind of issue should be addressed. At the same time, also when data is modified in the system, you should be able to, you should keep the log, actually the log file there, because people should come and see what happened to the data. The history of the data should be documented as well. So this was the requirement for us. And advanced technology, client-server architecture, single as well as corporate use, because the way it's going to be really varies. In some places, just standalone on a PC. In others, it just becomes institutional use, where a number of people really work on the same system. That kind of requirement should be taken into account. And cost efficiency, again, cost efficiency means not the embedded cost, but also the long-term cost of ownership is very important. So, with this, we went, we designed kind of 3 work packages for development. This is 1, development work package, 1. 2 is independent testing, which is very important, because, during development there's some testing as well, but we also need to do independent testing of the system by the users. And this kind of, the third one is very small work package for supervision monitoring. Okay, some lessons from the need assessment exercise. We observed that when it comes to transboundary issues, they were very common among the countries. Countries were concerned or more or less equally the same kinds of issues. So there are other national differences in some issues, because there were really many issues there. So different sub-regional or national priorities might suggest need for different regional configuration of the DSS, meaning basically means should be able to be configured as per the local needs, having the core transboundary issue being the same. All right. So for this reason, flexible design to allow future expansion of the DSS to address issues not taken for the first implementation is very important. So what we agreed with the stakeholders was, okay, these are the 8+2 for the first implementation. With a flexible design, it should be possible to expand this. That was the kind of agreement we had. All models and tools needed to cope with the key transboundary concerns should be included in the core. Participatory implementation, innovation, collective learning is very important, because this is really the first time in the Nile we have a DSS of such magnitude. So we're actually aware that there's a lot of things to be discovered as we start the development. So expectation management is very important. It's very key, because when we went out for the reassessment exercise and we said we are going to develop a DSS, and all kinds of issues were raised. Should address this, should address this, and so on. So expectation management is really very important, because people might really, have lots of expectations which you cannot fulfill at the end. It might lead to some kind of, a situation where the tool might not be even used. Okay, something about the organizational arrangement. The DSS is one component under a project in the DHI called the Water Resources Management Project. Just talk about only the DS arrangement. We have the regional office in Addis Ababa, a team of about 5 to 6 people, amongst them, and we have modeler, GIS specialists, and now we have also remote sensing specialists. We have also international advisory panels. Dr. Basson is one of the panel members. We have also core team. The core team actually is our national team. In all countries, we have 2 project hired staff and 2 government secondary staff. Basically means 4 times 9, we have 36 people distributed in 9 countries, plus 5 to 6 at the regional level and so on. So again, the national level, we have a team of about 10 to 15 people who occasionally interact. They get training on the DSS, they apply it on some project cases and so on, to have a wider group of users for the DSS. Okay, so now coming to the features of the DSS, So far it's about the need assessment and what the DSS was agreed to address. Now I come to the software itself. As I've said earlier, we started development May in 2009, and we are now like about 1.5 years before the final completion of the DSS. We already have a version of the DSS. We call it a release of the DSS. So the development for people who have some software background occurs in 3 increments. Each increment brings full functionality of certain selected functionalities, not complete DSS, okay? It's not a prototype, it's really a fully working system, but brings only certain functionalities. Ultimately, we are going to have 3 releases, and the final release is going to be the complete DSS. So, the overall layout looks like this. We have 3 blocks you see here. You may forget this one. Basically, this is block 1, this is block 2, and this is block 3. Block 1 is what you call basically the top, the application, the DSS application, what you call it. Block 2 is the modeling system. And block 3 is the database management system. Basically the database software, you can say. Okay. So, most of the development efforts are here. Because of the architecture, this two can be exchanged, they can be plugged. Different kinds of tools, different kinds of database can be plugged. So basically most of the developments are here. Okay? So talk about this one later. This red box means features which are planned for release 1, which we already have. Green is features which have been planned for release 2, which we expect sometime in October. And the yellow ones are the ones for release 3. So maybe with this short overview, I'll move into the actual features. Okay. First, the database management part of the DSS. I'll give some functionality, and then a screenshot of the DSS will follow for most of my slides. So the database side, one thing I like to say here is really all the data used in the DSS will be stored in one database, because we have decided we don't want to allow a situation where some data is in a file system, because that will have its own problem. Because one thing, you can easily lose data, it's difficult to query data, to find data, and so on. Again, because of the reasons I mentioned earlier about transparency in a very transparent situation, so we say we decided all the data, be temporal data like time series data or GIS data, will be in one database. Okay. Then this will help in systematic query functionality. It has systematic query functionality by name or by group, by map selection, which is very important. If a data is georeferenced, then you can find it either from the GIS map layer side, often from the data itself. For example, a time series which is linked with a gauging station in the basin, obviously it will have, it is georeferenced to the gauging station. So you can either select by finding those gauging stations for which there is some data already available, or by selecting the time series and then finding out where this is measured. So it has a multi-level user access control, which is very important. I mentioned to you earlier that some data is under restricted access, so you should be able to assign users different roles. Some users could be like super users, they have access to everything. Other users, they can have access to a limited part of the data. For this, we have implemented what we call partition in the database. So each partition will have its own users and then priorities. Of course, one user can have access to multiple partitions. That's the implementation side. But the system will offer you to implement this kind of data management policy. Basically means restricted access. Okay? So there's a lot of functionality for handling metadata, basically data about data itself, because this is very important. We want to keep track of how data was changed, by whom it was changed, and what type of data was changed, and where the data came from, and so on. Okay, when you open the DSS, maybe quick here, especially from the data side. Here you have the query tool. You can provide criteria. You can extend the criteria here for selecting any type of data. This is the data explorer. And this is the data view, where you can plot time series or maps or scenarios and other things. This is the metadata box here. if you click any data here, it will give you provide information about, for example, from when to when is the data, how many time steps are there, for example, how many missing recurs are there, this kind of thing. This is very important, vital information. And here you have the tool set available to manipulate this data. Basically, you need, for example, you have a time series data. You can see here a gap filling tool. That means this is context sensitive. It depends upon what data you have selected here. Okay, the same thing for this one. If you select GIS data, again, this will change. Again, this will change as well. Okay. So you have here tabs. Basically now here I'm showing only the time series tab. You can have GIS tab and scenarios tab, so you can simply select which type of data you want to explore. And this is exactly the same pattern whether you are dealing with the time series data or the GIS data or models or scenario and other things, which is consistent, which is very important from the user's perspective. Once they learn how to browse and find and manipulate and especially view time series data, the pattern is very similar to other types of data. Okay, this is what I mentioned to you earlier, multi-user access control. It means you have to log in to use the DSS, basically. So the administrator will set up a user account. So in doing that, then the admin will give a role for each user, which is, I just want to show this one. That means you have different roles, all right? And the study here is simply basically the file which you are going to create when you use a DSS. So that means the database is compartmentalized by studies. That means a particular user will have access probably only for one study. But it can also have, of course, access to other studies. So you can, basically, the main thing I want to show here is really, you can assign roles to different types of users, thereby restricting, actually, or protecting your data. Okay, time series functionality. These are some of the examples what you can deal with, available functionality in the DSS. Simple browsing, charting, simple aggregation, gap filling, georeferencing, extracting key statistics, empirical distribution, fitting theoretical distributions, quality assurance, quality control tools, correlation, regression analysis, stochastic generation of time series. This is not yet implemented. R2 means it's that for release 2. So there are other functionalities of time series, and this is a screenshot example. I think I've explained most of the things, except here you can have different types of charts. If you click the chart, the properties window will show only properties of the chart, which you can also customize the way you want the chart to look like. I'm sorry. On GIS, most of the features are not yet implemented, but we have to have them in the requirements list. Currently, you can visualize GIS layers. You can import, export GIS layers, especially from S3 formats like shapefiles. You can import or you can export as well. You can zoom, you can pan, kind of things, but more features are coming, especially for handling raster data, for handling grid data, for example. You will be able to delineate watersheds. You can do for spatial interpolation. I think it's already there. You can do zonal statistics, like, for example, for grids, for a certain area, you can calculate the mean, the maximum, whatever. And many other actually geoprocessing tools. Most of them, as I said earlier, are still not implemented, but they are on the agreed requirement list. Again, the pattern is similar, except here what you have is actually GIS layer instead of a time series. So, go quickly through this one. Another functionality which is now coming as part of our release 2.1 is the spreadsheet functionality in the DSS, because many people are used to spreadsheets, especially Excel. So that has been taken into account, and in the DSS, you will have a spreadsheet functionality. Meaning basically, within the DSS, you can run Excel type, it's not Excel itself, but Excel type spreadsheet tool, okay? But with the added advantage of all your data being in the database, you can query your spreadsheets, with that advantage, you have on top of it the ease of use of a spreadsheet actually functional, which is very critical, especially when it comes to see different types of users using the DSS. The other advantage is within the spreadsheet itself, the types of functionalities you can call is not limited by the spreadsheet tool itself, because you can also call other functionalities which are available in the DSS for some limitation as well. Okay, when it comes to modeling, we have three types of modeling tools. We have what we call the water budget allocation model, which we already have decided to take Nile Basin. And the hydrodynamic model is the one-dimensional Mike 11 from DHI again. We have two range runoff models, Mike 3 and NAM. This one has less parameters and less data need, and can be used for many places, whereas this one has a great data need, so it is restricted to areas where you have the data. But it is available for all countries will have the access to the complete set of tools. One thing which I'd like to mention here is the model tool set you have here can be expanded. Basically, we have followed what we call an open architecture for the design of the DSS, where the users can also add another modeling tool here and then plug it into the DSS. The only requirement is then you have to develop what we call adapter to link this new modeling tool with the DSS. Basically, the adapter will serve the function like transmitting information back and forth, basically, with the advantage of like you can invoke the modeling tool from the DSS, and then you can import your data into the database. Especially, this is important for us because, you know, as I said earlier, few countries have other modeling systems they're using now. So you can easily plug it into the DSS, and then finally you can even compare the results without the need to really go extra more into that. Okay, another feature of the DSS, which is part of Release 3, is what you call the model nesting, which is again very important. So when you are using different types of models, and especially when you are dealing with complex hydrology like the Nile, so maybe you will not model the whole Nile to the same level of spatial scale, for example. So in some places you will be more detailed, in other places you will be less detailed. Again, in the development process of the models, maybe you will experiment with a small section of the Nile and then with more detail, and then you don't want to repeat in the whole system later on. So what you can do is simply link them. Basically means an upstream model can be linked with a downstream model with what you call the model linking functionality, which means it gives you greater flexibility to use different types of model. You don't have to stick only to one kind of model for the whole system. You can still use different types of models and then bring them together, even at the application level, not at the program. I'm not talking about the programming level. Okay. Yes. What this example could be, for example, if you are interested. In our case, one thing we are interested to find out is impact of like flood damage mitigation in Khartoum, in Sudan, Khartoum area, because of the regulation dams planned in the upstream in the Ethiopian highland. Then one of our cases for application is modeling the upstream part using Nile Basin for water budget. There's no need to do hydraulic modeling there. And then modeling the lower reaches, especially in the Khartoum area, using Mike 11, and then linking the two together. Then they can run sequentially. This one will provide the boundary condition upstream for this one. So this kind of flexibility you have in the DSS through the model nesting linking. Okay. Scenario management. The scenario management we define for us, a scenario is a contemplated state of the basin induced either through target human intervention or through externality, for example, climate change or even different types of time series and so on. So here we want to combine what we call development interventions, basically what we commonly say structural measures, like dams, reservoirs and so on, or management option, different ways of operating your reservoir. So these are some examples from the Eastern Nile, where different types of scenarios may analyze. So how does the DSS support scenario, like defining scenarios? Because as we have said earlier, decision making obviously inherently includes choice making. Choice among alternatives. These are what we call scenarios. Basically, they are alternatives, meaning one alternative could be an upstream dam in Ethiopia, for example, with such and such size, plus this kind of operation route. Another could be like 2 dams upstream, or plus some other measures downstream. How does the DSS support the stakeholders or the decision makers later on in capturing all these different scenarios? Because if you are using a single modeling tool, obviously it is in the brain of the user how many scenarios you have, and plus the data you have in the hard disk. So in this regard, this is actually a key, sorry. So the DSS supports the scenario management by helping in defining interactive scenario definition, editing, by changing configuration of business development alternatives. Structural measures, management options, and input. Basically, the DSS will provide you a tool for defining your scenarios. That means the DSS understands if you have a group of scenarios in a particular study, then it understands they belong together. Again, it will help you in visualization of scenarios, in simulating the scenarios in the DSS, and comparison of the scenarios using some performance measures. This is an example screenshot again. This is partly released one and partly released. We have already some scenario management functionality except the graphic part. The graphic part is part of the release 2. Meaning basically if you have a schematic, a model schematic like this, then you can drag and drop, for example, these objects or like the elements of your system where you are going to vary to create a new scenario. Basically, visually you can define your scenarios. Okay. The other tool you have in the DSS will be an optimization tool. It's still under development. We are going to have what we call the multi-objective optimization, which is to take into account really multiple objectives, and we are using what we call simulation-based optimization for this. And this is going to be one of the added value of the DSS. Okay. Indicators. Here we have, when you say choice making based on some performance of your alternatives. A performance could be like, for example, maybe you are interested in energy production, or you are interested in reliability of water supply. You have so many other performance measures. These performance measures, we call them indicators. So they are not necessarily always about water, but you have your simulation output in terms of water level or flow and so on, must be translated into some other indicators, or some other performance measures which make sense for the decision makers. They may not be interested only to see hydrographs. In fact, in many cases, they are interested, for example, to find out, okay, how much is the reliability of supply, or how much damage has been reduced, this kind of thing. So those are for us indicators. So the problem with indicators is, especially in the Nile context, relating your simulation output with indicators is really difficult, especially when it comes to the environment system. So you are interested, for example, to find out how would a particular fish species be affected if the flow pattern changes. That kind of relationship is not easy. As maybe, I'm not sure, I don't know about Southern Africa, but at least in the Nile it's very difficult. So facing this challenge, what we did was, okay, we don't have the data, we don't have the relation, but we know it's very important factor. That means we have in the DSS a facility where the user can write a small code, basically a small script, to define that relationship between your simulation output and the kind of indicator you are interested in. So this is one of the values of the DSS. And we have what we call decision-making tools. Basically, we have the multi-criteria analysis tools and some economic analysis tools. Because of time, I have to maybe shorten my presentation. But this is really the final choice-making bits of the DSS. So this is still in release 3. It should provide the country with a very transparent way of comparing alternatives or ranking alternatives and so on. Okay, overall features, generic systems that can be applied at different scales, wide range of functionalities from data management to choice making through the MCA, configurable interface for web publishing, all data shall be stored in the same database, flexible expandable architecture, new module tools, new modules can be added, scripting through which users can extend available functionality or outcome for the automated repetitive tasks like for the indicator program. Support for multiple or simultaneous users through the corporate edition. So, few words about the development process. For each cycle, we start with the requirements analysis, which leads to the design approved by the client, and then development testing by developers, in this case DHI, and then finally delivery and testing by the client. We have an independent testing team for the DSS. This is actually distinct from the testing undergone by DHI. Our requirements are like, we have documented through a long list of requirements in a very standard professional way. We have a requirements document, we have a design document, we have also a user interface design document, which are actually quite distinct. So this is a list of our requirements example, and this is just, a snapshot, a cutout from the design. Okay, testing, as I mentioned earlier, we do testing ourselves. We do different types of testing, user acceptance testing, system testing, operational acceptance. We're still awaiting the final release for this one. Our team heavily participates in the test. That's very important. Our team are technical users, and they participate in testing the software. Okay, this is just an example of testing results. Okay, testing is on the software side, and the same on the application side. We have what we call the pilot application, meaning we test the system, we fix the bugs through the developers, and then we have a stable system, then we apply it on a practical case. That's what we call the pilot application. So we have national as well as regional application. As the regional transboundary layer, we have selected 3 project areas, which are active project interests of the countries, where we really apply the DSS and demonstrate the use to senior people, planners or decision makers who are not really modelers. So based on this is actually an area where we are using it as a tool for promoting at the same time the DSS plus the testing of the DSS. So we have some examples of that from maybe later on in the question and answer section I might say thinking about it. Yeah. Okay, this is the final, almost the final slide. Key lessons, expectation management, as I said earlier, is very important. People should be aware what it can do, what it cannot do, for example. Maintain stakeholder interests is very important because this development is taking more than 5 years. People should be kept on the radar screen, and we should start to show some results. We need to understand who are the future users and what kind of type of users. That's very important for a software system. Involve future users at appropriate level. Capacity building is very important, very critical, and they should consider cross-section of future users, not only modelers. When you say capacity building, it's not only about modeling. It could be about data management using DSS. It could be GIS data manipulating in the DSS. So that is really very important here. Requirements, this is requirements gathering, design, development, and testing is an iterative process. So plan ahead with adequate slack, because what we have observed is that this really takes time. So you need to have adequate planning, keep the flexibility, because we are developing the DSS about the future, and the future is uncertain. So you should have some flexibility in the system which can absorb some kind of changes in the setting in the future. So I mean, this is a quotation of one of our advisors said, software systems are like organisms. If you don't feed them, they die. That means you have to feed them. Basically means you have to maintain them. Once you have them out, then you have to maintain them. Otherwise, it doesn't mean that you have a software system that will work by its own, because very simple, operating system changes, then the system should work on the new operating system. Who's going to make sure that it's really working? So sustainability is really very important. So I think that's